are everywhere in calculus, but how do we know where they actually work? In this tutorial, we'll explore radius and interval of convergence, making this concept easy to understand. Let's dive in and unlock the power of infinite series. Understanding power series and their radius and interval of convergence is crucial because they help us determine where a series represents a function accurately. This is especially important in calculus, physics, and engineering where power series are used to approximate functions, solve differential equations, and even develop computer algorithms. Knowing where a series converges ensures we use it correctly in real-world applications. Understanding power series. A power series is an infinite series that look like this. A sub 0 plus A sub 1 x plus A sub 2 x squared plus A sub 3 x cubed, and etc. Each term has a coefficient and x is the variable. Think of it as a never-ending polynomial, but not all power series make sense for every x. To figure out where they work, we need to check convergence, which brings us to our next topic. Is finding the radius and interval on convergence. The radius of convergence is denoted as r, tells us how far from the center a power series remains valid. Mathematically, we find it using the ratio test. Series of a raised to n plus 1 times x raised to n plus 1 over a sub n times x raised to n. If this limit is less than 1, the series converges. The radius of convergence, or r, is found using this formula. R is equal to the series of a sub n over a sub n plus 1. This means that inside this radius, the series converges and outside it diverges. The interval of convergence. Once we have the radius r, we can find the interval of convergence, which tell us the full range of x values where the series converges. We have an example. If our radius is equals to r and the center is equals to 2, then the interval will be x is greater than -1 but less than 5. But we can also check the endpoints separately because sometimes the series might converge too. Let's have an example. For example number 1, series of x raised to n over n factorial. First, we will be using the ratio test. Let's substitute the value using the formula. Series of a raised to n plus 1 over a sub n is less than 1. Substitute the values of the given series. It will become the series of x raised to n plus 1 over n plus 1 factorial divided by the value of our given, which is x raised to n over n factorial. Next, we need to cross multiply it, but first we need to get the reciprocal of the other function. Limit of n to infinity is equal to x raised to n plus 1 over n plus 1 factorial times the reciprocal of the function n factorial over x raised to n. Next, we need to distribute the values into x raised to n times x raised to 1 over n plus 1 factorial n times n factorial over x raised to n. Since nakakakita tayo ng same, we need to cancel it out. Let's cancel x raised to n and n factorial. The function will become 1 over n plus 1 times the absolute value of x. Since therefore, our radius is infinity, and our interval is negative infinity and infinity. Let's have another example. Series of x raised to 2n over 2n factorial. Using again the ratio test, our formula is limit of n approaches to infinity times a raised to n plus 1 over a sub n less than 1. Substituting the values, it will become the series of x raised to 2 times n plus 1 over 2 times n plus 1 factorial divided by the given function 2x raised to n over 2n factorial. Next, we need to get the reciprocal of the another function. It will become the series of x raised to 2 times n plus 1 over 2 times n plus 1 times it's the reciprocal of the another function, which is 2 times n factorial over 2n x raised to 2n. We need to distribute each values that are raised. It will become x raised to 2n times x raised to 1, 2 over 2 n plus 1 plus 2n minus 1 times 2n times 2n factorial over x squared n. We need to cancel out yung magkakaparehas ang value. Therefore, it will become 1 over 2n plus 2 times 2n minus 1 times x squared. Therefore, our radius will be equal to infinity and our interval is negative infinity and positive infinity. And that's it. Keep practicing more example and soon you'll master power series. Thanks for watching. Don't forget to like, share, and stay curious. See you in our next tutorials.